All right, in this video, I'm going to walk through getting Derby, the Derby database, set up inside your NetBeans project. So the nice thing about Derby and the reason why we use Derby for this class is that um, Derby's a pretty simple and easy to use database service. Derby actually doesn't run as a separate program. Derby is a library that runs entirely inside of your Java program. So in order to get started with Derby, all you really need is the jar file. So I'm going to start a new project, just like any other, called Derby demo. And I'll create a main app class. All right. So I don't need to do anything special to start the Derby database. All I need to do is locate the Derby jar file and include it in my project, and we'll be able to use the Derby libraries to create our own database in a pretty straightforward way. All right, so fortunately, most Java installations come with the Derby jar file. Basically, it's pre-downloaded onto your computer, and you should be able to find it. So I will show you where it's typically located on a Windows computer. It's going to come with your Java developer kit, your JDK installation, which you should have. It's required in order to run NetBeans. So this should already be located on your computer. So in order to add it to your NetBeans project, it's just like adding any other jar file to a NetBeans project. You want to right-click on the Libraries folder and go to Add Jar or Folder. And I've actually already located it on my computer, but I'm going to walk through where I ended up finding it. You'll want to go out to your computer overall and probably onto your C drive or wherever your Windows Program Files folder is located. You want to know where that is. Again, I'm walking through from the Windows perspective, but really you just need to know where Java is installed on your computer. So in Windows, that's typically going to be in Program Files. Oops. Well, let me open it. All right. And then inside Program Files, there will be a folder called Java, of course. And then you may see several different folders inside of your Java folder. What you're going to be looking for is the highest number JDK folder. And the JDK part is important. That stands for the Java Developers Kit. The JRE folder is what most people have on their computer, the Java runtime environment. It's what's required in order to run any Java programs. The JDK, the Java Developers Kit, is typically something that's only installed for Java developers like you and I, and it usually comes delivered with NetBeans. So you should have this JDK folder. If you don't, you can Google Derby, Java Derby, and look for the jar file that way. It should be on the Apache website, and I can post the link of that in Desire to Learn. But assuming you have this JDK folder and you want to look for the highest version, 1.7 or 1.8 preferably. Oops, went too high. Inside that folder, you'll find another folder called DB, short for database. And inside there, you'll find a folder called lib, L-I-B. And probably the first or close to the top file inside that folder is going to be a file just called Derby. It's actually called derby.jar. That is a jar file, but just has the name Derby. You don't want any of the other ones. You don't want derby.war. You don't want any Derby client or anything like that, just Derby. All right, so select that one. You'll see the file name down here, derby.jar, and you can hit open. And again, just like adding any other jar to your NetBeans project, you'll see it appears in your library folder here. This does not mean that Derby is included in your project. So if you zipped up your project and emailed it to me or anything like that, the Derby jar file is not copied into your project. It's just saying that your project needs to have access to the Derby jar file. So if you move this project onto a different computer or something like that, you will need to re-add the library, the derby.jar library on that different computer. So just bear that in mind. All right, so now that we have the derby.jar file, we can use Derby inside of our code. We don't need to start a big program or set up any kind of administrative user or anything like that, which you would need to do with a larger database system like MySQL or Oracle or something like that. All right, so we can just start writing code, and I'm going to just give a quick demonstration of connecting to Derby, probably creating a table inside the Derby database, and then maybe inserting or reading some data. And I'm just going to break it out into those component parts, do kind of a top-down design here of the different things that you'll be doing with the database. Probably the first thing that we want to do is open a connection. I haven't created this method yet. I'm just kind of outlining the program. So the first thing we'll want to do is open a connection to our Derby database. So I'll make a method to do that. The connection class that you'll want to import will be the java.sql.connection. You should know that from reading the chapter in the textbook. All right, so we're going to make a quick little method here just for opening a Derby connection. I'll make a quick little method for creating a table, one for inserting data, and one for read data. Okay, so we'll just sketch out some quick methods here just to show the different bits of functionality. Oh, these are all going to need access to the connection object. And then at the end, we'll end up having to close our connection. So there's that. All right, but we'll come back to this in just a second. I'm going to show you guys quickly how to open up and connect to a Derby database. All right, so I want it to return a connection. All right, so there's a little bit of setup work involved with connecting to a Derby database, or any database using Java for that matter. Because Java through JDBC, Java Database Connectivity, Java through JDBC is designed to connect to pretty much any relational database system that's out there on the market. But in order to connect to a specific type of database from a specific company, you're going to need the implementation code for that database, what's commonly known as the database driver. Okay, so with Derby, you're going to have one database driver. With Microsoft SQL Server, you're going to have a different database driver. Okay, so just bear that in mind, that loading the driver is going to change depending on which database system you're using. All right, and it's always the same process. You call a static method of the class called forName, and the forName method is a special method in Java that's responsible for loading classes. Okay, so the forName method is going to allow us to load a special Java class, in this case the Derby JDBC driver, into our program. And you'll need the full class name for that driver. Let's see, I have it over here in my documentation, so I'm going to copy that. And then, of course, I'll have this uploaded to Desire to Learn, so you can copy it from me. All right, so this is the name of the Derby JDBC driver class. Right now, class.forName can throw an exception. It'll throw an exception if it is unable to locate the class that you're trying to load. So I need to bracket this whole thing with a try catch. Okay. And if we do catch, actually we'll just do print stack trace. That'll give us the most helpful information. We'll print it to system.out. Okay. All right, so this line right here is going to load up that driver for us. And if it can't find that driver, for example, if we failed to include the derby.jar in our project, then it would throw an exception there. Another line of code, once that driver is located, we can request our actual database connection from that driver. So what I'm going to do here, because we're going to need to return it, we'll create a variable to hold it. Right, and we'll return that variable. And the way we actually access our database connection is by calling driver manager.get connection. All right, I'm actually just going to need one parameter here. All right, and I have this in my notes as well. So this parameter right here is what's commonly known as the JDBC connection string or connection URL. And this string is basically going to describe the database that we're connecting to in a very specific format. And that format, much like the driver class, also changes depending on the database that you want to connect to. So again, when you're looking through the chapter, through the textbook, at how the author connects to a MySQL database, this connection string is also going to be different from what I'm showing you now, but reasonably similar, right? Just Derby does things a little bit differently. So the first thing we need in the string is we need to declare that this is a JDBC connection, and we need a colon, and we're going to declare that it's a Derby connection, all right? And then after JDBC colon Derby colon, we get to provide the name of our Derby database. I'm just going to call it products. I'll just make it all capital so that it stands out, and you'll see why we want it to stand out in a second. So you can just make up whatever you want for this. This is going to be the name of the actual database. All right, and then after the name of the database, we're going to put a semicolon to indicate that this is the full connection string for the database we want to connect to. We're also going to supply an optional parameter, create equals true, and this optional parameter declares that if the products database does not already exist, Derby should create it, okay? So this entire string here, again, states that we have a JDBC connection to a Derby database. That database's name is products, and if that database does not already exist, please create it. All right, so we're doing a lot here just in one line of code. And when this line of code is finished, it's going to give us a connection object to access the database, and we're going to assign it to the variable con. This can also throw an exception, an SQL exception. So I'm going to add another catch clause here. And basically do the same thing. SQL exception does need to be imported. All right. So this is connecting to a Derby database. Very simple process. You load the driver, and then from the driver manager, you request the connection using the appropriate connection string. Okay, very straightforward. So that's all this method is doing. It's just loading up our connection object and then returning it back to the main method. All right. So that's connecting to the Derby database. Let's dig into actually creating a table. And I'm doing this all in static methods just inside the main app. Obviously, for the project, you're going to be doing this stuff in a similar capacity inside of your DAO implementation. And we're going to pass our connection object to each of these methods, because now that once we have an open connection, this is how we're going to interface with the database itself. All right, so creating a table is just a matter of running a prepared SQL statement. And this is all right out of the textbook. We're going to ask our connection to prepare a statement for us. create table product. And let me see here. We want our table, I'm going to make this capital. It's a popular naming convention in databases to give things capital names. All right, so what is our product data? We're going to have a name. And let's say that can be, I don't know, 200 characters. It seems like a lot, but that's fine. So we have a name. We have our UPC, which we know is exactly 12 characters. And then we have our price, which is just a float. It's a decimal number. Okay, so you don't need to be super familiar with SQL here. I'm going to provide you with the SQL that you need for the project when it's time to do that in the project. So don't worry about this too much if you haven't taken the SQL concepts course. I'll give you what you need to know. All right. And I need to import prepared statement. Okay. Now, of course, just like any part of Java that interfaces with an external system, like a database, there's the potential for an exception. This statement right here can also throw an SQL exception, so I need a try catch here. To deal with that, let me collapse this. And again, we're just going to print out the stack trace. All right, now once the statement is prepared, it's just a matter of calling statement.execute. All right, and that'll create the table. So this is great. It'll create the table for us with these three columns, the name column, UPC column, price column, which is exactly what we need. But it's important to keep in mind that once the database has been created, you won't need to recreate the table each time you run your program. So that'll actually cause some errors to pop up if you try to recreate the table each time you run your program, because presumably your table is going to last between program runs. So you'll need to have some logic in here to basically detect if the table already exists or not. Fortunately, our database connection has some information called the database metadata that's going to pretty much tell us what the contents of our database already are. And I'll provide you with this information as well. Basically, what this method is going to be doing is looking for tables with the name product. Okay, and these parameters, these optional parameters, are not necessary, but that's essentially what this method is doing here. There we go. All right, I knew I was forgetting something. This is a shorthand just for creating an array on the fly. This fourth parameter, it turns out, requires an array so that you could potentially provide multiple parameters. Like if you wanted to search for both tables and views, you could provide multiples, but we're just looking for tables. We're essentially just looking to confirm whether or not this table called product was created on a previous run of the program. All right, so when you run this line of code, it's going to return a special object called a result set, and you'll learn about result sets in the reading as well. And it also needs to be imported, of course. Okay. So this result set is going to contain, if there is a table named product in the database already, this result set should contain a record, a result. And basically all we need to do here is to make sure make sure that the result set does not contain any results. Okay, so by checking to see, this dot next here will return false if there are no results. All right, so if checking to see if it's not false, checking to see if there are, or not results, then we know that it's safe to go ahead and create the table. So again, what's going on here, we are querying the database's metadata to see if there's already a table named product. Okay, if there is a result, we're going to skip executing this statement, right? And that's all we got to do there. Okay, so if there is no result, we'll create it, and then we'll have our table in place, our product table. Okay, so we've got opening our connection, we've got creating our table. Let's actually put some data into the table. We're going to need some data. I'm going to go ahead and grab the product class that I've been using for these examples. Okay. There's our typical product class, name, price, UPC. We've got all the data. And let's just create some products. I'll make a product array. Actually, make a product list. Call it inventory, new array list. Okay. And we'll just start, I've got to do my imports first. Good. We'll just start adding some new products. I didn't look at the constructor here. Constructor goes name, price, UPC. Okay. So we'll do banana, $1, and UPC. Okay. Let's add a few. All right. Get a few products going. So we'll do apples at 60 cents. Make sure we get some unique UPCs here. Oh, forgot to add onto our table creation here that we should really be using the UPC as a primary key. Okay. Basically, what that's doing is indicating that the UPC should always be unique on our table. It makes it a lot easier to look products up by using their UPC. Okay. All right. Oh, I need. Let's make our keys $2. Watermelon is going to be $3. Okay. That looks all right. And then we're basically going to kick into a loop here. And we're going to insert all these products into the database. All right. So we've already got our connection. Basically, what we need to do is another prepared statement. This is how we execute our SQL. Insert into. Okay, I want to be consistent here. All right, and the values, we're going to be inserting 3 values. All right, I'm putting question marks in here for a good reason. Our table has 3 columns, so we're going to be inserting 3 values. The reason why we use question marks here is so that we can basically connect our Java variables as SQL variables. you may think, all right, and this is a popular misconception, you may think that you could just insert the values, doing the following, using string concatenation like that. Never do this. Never, never, never do string concatenation inside of an SQL statement. It's a very common security vulnerability. Basically, what happens is somehow an outside user gets access to put a string value in this variable, say a savvy cashier at this grocery store where we have all these products, changes the name of banana to something like drop table product, right? And that's a SQL statement that would cause our product table to get destroyed. It's a popular security vulnerability known as SQL injection. And the #1 way to combat SQL injection is to use what's called bind values or bind variables. And that's what these question marks are going to represent. So the way we actually assign a Java variable to an SQL variable, these are our 3 SQL variables, is by the following. Name UPC price, okay? All right. Oh, this wants me to convert. We'll just do. All right. So essentially what's going on here is we are connecting the 1, 2, 3 SQL variables to our 1, 2, 3 Java variables, the product name, the product UPC, and the product price. So the order is important. The order in the table here is name, UPC, price. So we want to do name, UPC, price, name, UPC, price, 1, 2, 3, okay? And notice that for price, instead of using set string, I need to use set double to indicate that the variable that I'm connecting to the SQL variable, it's not a string, it's a double, it's a decimal point number. We're getting the red underlines here because there's the potential for any of these lines of code to throw an exception. So I need to surround all these. Okay. Right, so once we have connected all of those variables, we can execute the statement. And that will insert that row of data for that product into the database. Now, since this is in a loop, we're going to do this 4 times, banana, apple, kiwi, watermelon, right? And it'll insert the new data each time. And then finally, once we've got all that data in there, we're going to try to read it back out. Interconnection object again, of course. All right, and we're loading the data in using an array list. So similarly, when we get it back out, I'm going to stick it in an array list. This is going to look a little bit different because We don't already have any data to loop through, but we are going to have a prepared statement. And since we're going to have a prepared statement, I know we're going to need a try-catch here for the potential SQL exception, all right? We're going to run some SQL here, and this time it's going to be a select. Select name, UPC, and price from product. Right, and this is going to give us all of our products back out of the database. So we have no bind variables here, no question marks or anything like that. So in this case, instead of just executing the statement, we want to run what's called execute query, because execute query is stating that there's going to be results from this SQL. There's going to be data coming back to us from the SQL, and that data is going to be captured in a result set. So by running this SQL statement with execute query, we will get this data back in a series of 4 rows, all right? And the way you read data through a result set, it's not like a collection in Java. It's not like an array. It works more like a scanner. Basically, you have to poll the result set. You have to ask it if there's more data to read using rs.next. So what rs.next does is it goes and it fetches the next row of data. But if there are no more rows of data, it returns false. So we can build it into a while loop as follows. So this will go through the entire result set until there is no more data to read back from the result set. So for each row that we read back from our result set, we need to create a new product object. And then we need to set its fields using the data that we get back from the result set. So set name is going to look something like this. We're going to get from our result set the value in column name, and then assign it to our product object. And with UPC, and then with price, we have to use, again, result set.getDouble, because we want to get double data back, not string data. Okay. And then once we've read all that in, just add it to our list. Okay. And then afterwards, we can loop through that list and print everything out. Okay. All right. And then finally, inside of our main method, closing the connection can throw an SQL exception. So let's patch that one up as well. All right. So to break it down again, we've basically chopped this up into 4 parts. Opening the connection to the Derby database, which will also create the Derby database if it did not already exist. Creating the table inside the Derby database. Inserting data into that table. And then reading data back from the table. I'm going to cross my fingers and hope that this runs flawlessly the first time. But I'm going to guess that it won't, because, well, that's just my luck. Okay, so there was an error here. And And I think it has something to do with the format of my SQL statement, specifically for creating the table. So let me take a look here. Yeah, we can see that there was some issue with the way my SQL statement is formatted here. So let me take a quick look. I think that may be required for declaring the primary key. Okay, there we go. All right, now we've got some success here. It actually ran through the whole program pretty quickly, and you don't really get to see much because we didn't put a lot of outputs. But what we do know is because we actually did print out these 4 products here at the bottom, they were successfully stored in the database. We wouldn't be able to print them back out if they hadn't been read out through the database. Before digging through what happened here, I do want to point out that if you look in the actual file folder for your project, after you run your code that creates the database for the first time, you will find a folder inside your project that contains the necessary database files. Now, it's important to understand that you can't actually open up database files and inspect them like you would text files. Databases they're not organized in a human readable way. You really have to use some kind of database reading program to be able to access them. But we can see that the database actually exists and can be used by Derby. And I'm going to run this again, knowing full well that there are some problems that we're going to run into here when I run this the second time. But I do want to point out that when I run it the second time, it will not recreate the database. The data will still be in there. We're going to see some errors here, I believe. Yeah. So what we're going to see here when I run through the program a second time is it's going to try to insert those same 4 fruits with the same 4 UPCs back into the table again. So we're going to see some errors here. Because Derby is not going to allow a duplicate UPC to be inserted into the table. However, if I scroll all the way down to the bottom here, it still is able to read the existing data back out of the table. All right. So hopefully you guys can use this as a starting point to get a Derby database into your projects, get a table created. As I already stated, I'm going to provide all of the SQL for you. All right. So be looking out for that. And so that you can create the tables with the appropriate columns and things like that. So you don't have to be SQL experts to get this going. And hopefully also the textbook and, of course, the internet are valuable resources for you guys on this as well. All right, so again, this code will be uploaded as usual to Desire to Learn in the demo section, so look for that, and you can, as usual, direct any questions to the questions and answers board. Thanks.